I am Kwame Yaskill Jafrican Beneden, Site Manager with Penalty Group. I'm standing at 69 Torbury Road, Smart Stop Storage Facility. I am the Site Manager on this job, and it's a 4-story storage building. Now last post, which was last week, what you saw was just foundation, and we were ready for structural steel. At that time I told you we were 3 weeks behind based on the wet spring we got, but my, what a difference can a week make. So a lot of times, you know, the owner's representative and the owners and even my office get nervous that we're behind and so on, and I kind of blot out the noise because I know what I can deliver in a short period of time. So as I said last week, steel is delivered in divisions. So if you look north, that's actually division 1 steel, and it's up, and at the very top there are some members spread, and those members are called open web steel joists, and they will carry the deck and then ultimately carry the roof. Below the members, the beam, all the beams that are going east, west, and north, south, they're called sin beams. And the beauty about these beams is that they don't require as much post erection work as the open web steel joists. Normally on buildings, all the floors are open web steel joists, and they require a lot of work. So I'm confident that since we're using sin beams, I'll be able to catch up that 3 weeks that I'm behind. So what I'm going to do, I'm going to walk you through where we are, and I'm pretty proud of all the things that we were able to accomplish last week since our last post. So power has to come to the building from, we're in Toronto, so from Toronto Hydro, but the power coming to the building is high voltage, and we don't require all that voltage. It, quite frankly, will kill us and fry our equipment that we're going to have in here. So what we got to do is that we got to put in a transformer, but before we put in a transformer, we have to put in a transformer pad. So if you proceed this way with me, right over here is the transformer pad, and we got that in last week, and the 4 steel posts around it are called bollards, and they have to protect the transformer so somebody don't come in here with a truck and back up and hit the transformer, because that stuff has a lot of voltage, maybe, I don't know, 1200 volts, 12,000 volts, I don't know what it is, but it steps it down. We only need 600 amps inside the building, and maybe, I don't know, 600 volts. Now once the transformer is placed, the wires from the transformer need to get to your building electrical room. So the site electrical contractor last week installed the hydro pad, or the transformer pad, sorry, and they also installed the ducts that are gonna take the wires, power wires, from the transformer into the building electrical room. And a bit later we'll go into the electrical room. Now in here you can see I got 5 ducts, 5 big ones and 2 small ones, and the 3 at the bottom are probably for power, and the 2 at the top are for communication, and the 2 small ones are probably for my parking lot light. I mean, I have 1 parking lot light somewhere over there. If you come this way, I'll show you now going into the transformer pad. So here's the same ducts going to the transformer pad, and usually they're on carriers, and we have rebar in between the carriers, and then we pour concrete over it. Now the reason why we left this portion open, the hydro inspector should come on Friday to inspect it, never showed up, so we told us to take pictures and leave a portion of it out, so hopefully he comes tomorrow and he can see it. Now we had a close-up of the hydro duct bank, so close-up of the transformer pad that's in, and of course the protective bollards are there to protect it so trucks and vehicles don't back up into the transformer. So we'll proceed around the outside of the building. So these are storage tanks, and these have been put in for a while, and what the city forces you to do now, sewers, water mains, well, storm mains really, are designed for what we call a 100-year event. So every 100 years we used to have these big events and we get a big deluge. So we design our system for that capacity. But as fate would have it with global warming, we're having 100-year events much quicker than 100 years. So if you have a big deluge, the storm system can't handle all the water surge. So what the city does, it forces you to retain water on your site. And what a creative mind have come up with is, instead of building big open detention ponds, you build storage ponds underground, which allows you to use the space above it. So this is one such. And if you look far against the fence, do you see that half dome? That's what it looks like. And it's in the ground, pipes run to it, it stores the water, and it slowly lets it out into the city sewer system. Of course, this is the storm pipe going into the building. It's going to collect the rainwater coming off the roof. Of course, this is Division 1 steel going up. Now, my job as a site manager is to really manage the trades, coordinate all the activities, and make sure that things go according to plan, and pick up things when they're not going right. So I'll show you something that's not going right that we're going to have to address. Now, here is where I have rolling overhead doors, and these are going to be lockers or storage that people can access from the ground floor without going into the building. And these steel members are supposed to carry the doors. If you notice, these steel members are inside the door. They should be sitting on this concrete ledge here. This is where they should be sitting. But the steel fabricator made a mistake. Those supports should have been back here, so that these one line here and one line here, and it should carry this. This one should carry the door here, and this one should carry the door on the other side. But look how it is. And even over here, this one should carry the door that's going to be here, but look how close it is to the column. It should be somewhere over here. So that's something that I have to take up with the steel fabricator. I'll show an instance where it's done right, and then you'll understand what I mean. If you look at this one, it's pretty close. It will carry the door. And if you look here, these two, they sit on the concrete. So this is perfect. And if you notice they're floating, it's because I'm going to pour the floor. And when I pour the floor, we'll bolt it into the floor. Along with working on steel last week and working on the electrical site services, we're also doing the grading. So around the building was too high. We have a grading contractor, and his job is to cut it down to below asphalt. And asphalt is not just the asphalt on the ground. This is called a subgrade. We have to engineer it up to the underside of the subgrade. So another contractor is going to come, and he's going to put down graded granular material, a granular A, and that granular A will go to the underside of asphalt. So this guy is way below asphalt. He's like, I don't know, 300 below asphalt, because you have to build it up with about 200 of granular A, and then I think it's 80 of HL8 and 40 of HL3. That's just the makeup of the asphalt. There's different types of asphalt. One is the base and one is the top. I know you don't know that by driving on the road. You figure just asphalt, but it's not just asphalt. There's two different types of asphalt, a base and a finish. We'll continue. So all this is material that's been pushed by the contractor doing the site grading. Over here, same thing. This is a storage tank, like the storage tank over there. These two storage tanks, this one and the one over there, will not be covered by the grading contractor because they're too high. So we can't put, the grading contractor is basically putting dirt down when they're very low, and then the contractor responsible for grading to the underside of asphalt will come and put granular material down. But because these are too high already, we can't put any dirt. They have to be graded material only. So my site grading contractor will not be putting any dirt on top of these, and we'll leave it to the fine grading contractor who's going to put on the granular material to put that on top of these tanks. That's all we can do, 12 inches. So you'll see, you'll understand more as we go along, because I'll show you the other two tanks that are completely covered with dirt right now, because they were low enough that we could put dirt on top of them. And then of course the granular material. And every time we build a structure, if we build a road, if we do slab on grade, we have to put graded granular material. The reason is these material has to be compacted to a certain standard. And this is usually a standard called Standard Proctor Dry Density Test. And it's a test that was developed that allows us to test the moisture content of the soil and allow us to know if it reaches a certain design compactability. So we'll continue walking to the front of the building. And if my lovely assistant could just pan to the south, you can see structural steel division 1 is pretty much up. There's a lot of fine tweaking that needs to be done, lots of bolts that need to be tweaked. But the first step is to throw up all the steel, for lack of a better term. Throw it up real quick, then you come back and you do all the fine tuning, and then you put the deck on. It still has to have deck, because every floor is going to have concrete poured on top of it. So there's a steel deck that goes, then welded wire mesh, and then concrete is poured. So as this area here comes on, it's a tank, and it has been completely covered by my grading contractor, because this one was low. So we're able to put dirt on it, and then the contractor who is responsible for doing the fine grading will come and put the granular material on it, the compactable granular material on it, in a week stay. We'll be out here, and this will be compacted, and then it will be asphalted. So we'll continue. It's nice to grade it, nice. If you look along the side of the building, you can see different elevations, different slopes. It's because the asphalt has to slope to all my catch basins. And catch basins are really just inlet into the storm pipes. And those inlets will collect the storm water, send it to the storage tank, and then slowly let it out into the municipal system. If you notice, this is graded high in a rectangle. It's because this is going to be a little island. And these are all grade sticks. The surveyor came and shot grades and gave us the grades, and then the site grading contractor extended them and put his marks on it so he can test. He can work to the elevations that he's supposed to. These are all showing we're going to have curbs out here. Curbs. These are the elevation and marking out of all the curbs. And of course the grading contractor is graded. You can see he has graded here and cut it. And the curbs. So the next 2 weeks when we post that video, you'll see the curbs in. We have a sidewalk up so you can see they cut it. We're going to grade it, put the compactable material to the underside of the sidewalk, about 8 inches of granular A, which will be compacted, and then we'll put the sidewalk on top. In this portion where I'm walking here is another storage tank. You can see some of it there, and they have a graded and put dirt on it because it was really, really low. Right, so they were able to put dirt on it, and then the fine grading contractor will come a week today, and he is going to put the granular A material on it, which will be compacted, and then from that we'll be able to put the asphalt on top. Forward to see it. Then I'm walking another storage tank. Here's the inlet, the catch basin that will collect the storm water and send it to the tank. This here is a box that I did. And the reason why I did this is I gotta put a sign base here, and this sign base is so close to the storage tanks. I didn't want to cover everything up and then to come and drill with a machine later on to put in the base, and by accident the guy bored the pipe for the storage tank. So I boxed it out so he knows this is the only area he can put it in. He cannot make a mistake. My job is to prevent mistakes from happening before they happen. measure all the heavy equipment that we use by the contractor to do all the grading. Down here we'll have some curbs on that side, but as I said last week, that fortunately or unfortunately, construction is not really a linear process, and you have to do many things at once. So I have to work on the outside and I have to work on the steel at the same time. So this is graded, but if you notice I have a ramp put back. It's graded all the way outside to match where the new curves are gonna go. Really, the ramp shouldn't be here. The ramp should be taken out and this should be filled with granular material. But if I take out the ramp, how is steel gonna be delivered? So I gotta keep the ramp. I work, I take the ramp out, I do my grading, I put it back. The guy brings the steel in, I take the ramp out, I do some more work, I put the ramp back. So if it's a logistical nightmare, then I won't asphalt this portion. I leave it out and so he can have access. Now the asphalt I'm putting down in 2 weeks is just a base asphalt, it's not the top, the final. So if I have to come back and cut and patch and add a piece here and add a piece there, it's not a big deal. The reason why I'm pushing to put the asphalt is that we're standing on dirt. And even though I'm going to put granular material and compact it, it's still, when it rains, it still get wet and it can still get soggy. The asphalt not going to get soggy. And I'm going to, in a few months, I'll have all kinds of machine running around here, putting on rooftop units, putting on roof, putting on siding, all the exterior cladding, doors, windows, blah, blah, blah. It's better they're driving on asphalt. So that's why I'm rushing to put the base asphalt on. Now we're proceeding inside the building. And you get a better view of the progress of the steel. This is 1 week of steel erection. And as I said, I'm pretty proud of the progress that these guys have made. Division 1 is to my left, which is north, and division 2 is to my right, which is south. So they've turned up all the steel, but if you can see some members that are not bolted and whatnot, and you can't see it, but I can see it from my vantage point where certain nuts are not in. They probably just put one nut in on either side of the beam to catch it. But that's the process. You throw up the steel, and then you spend time fine-tuning it, putting all the bolts, torquing everything, and then I call the steel inspector in to inspect it, make sure it's plumb. And once he gives me the go-ahead that it's plumb, then they come and they put the deck in. If I forget to call the steel inspector and they put the deck, then I'm euchred. Once the deck is in, the steel is going to stay the way it is. It won't be plumbed after that. So basically I have to be on top of the ball. I can't miss something. Of course, this is all the steel that has been laid out. When the steel comes on the flatbed, these guys lay them out so that they can pick. Believe it or not, they look chaotic, but they're all tagged. These pieces are all tagged, and he has a bill of lading with all the tags, and he matched the tags to the beams. Then he has a drawing that tells him where each of these beams go, and those tags on the delivery tickets match up with the tag on his drawings. So it might look confusing to the untrained eye, but it is not confusing. It's actually method to their madness. So we're gonna walk out the electrical room to show you the electrical ducts now into the electrical room. Ducts are in the electrical room. Yours truly laid out the electrical room and tell them where to put these. Marked out the back. You can see marks on the ground, that's where my wall is. And they bring it up on the back of the wall. This is where the electrical services will come in. And then they will come to their disconnect and then connect from the disconnect to splitters and whatnot and make its way through the entire building. And of course, this is my telephone. Telephone comes up here, and this is the power for my parking lot light. And over here, yours truly again, lay these out. This is your water main coming in, and from here they will have a tree, literally a horizontal tree with the meter and the backflow preventer and whatnot. This one here is the sprinkler main. There's a wall that's going to run here, and it's going to run along that wall all of the sprinkler distribution. And so that's that for this week. Until next posting next week, you'll see way more progress.